Hey Opties! Today we're talking about parallel lines cut by a transversal. Recall that parallel lines are lines that never touch each other and they're in the same plane. So they're in the same two-dimensional surface. So we've got lines and they've got the same tilt. That's what parallel lines mean. A transversal is just a line that cuts across parallel lines. So there are some interesting things that happen when a transversal cuts across parallel lines. You can get some congruent angles, which means angles that have the same measure, and you can get some supplementary angles, which are angles whose sum is 180 degrees. As we can see in our pictures, we have 8 angles that are formed if you have 2 parallel lines cut by one transversal. So we know these 2 lines, let's call them M and N, are parallel lines because of these arrows. Since the arrows are pointing the same direction, it means they're in the exact same direction, which means they're the same tilt and they're parallel. And this line here, we'll call it Q, is our transversal. And that, again, that's just a line that cuts across the parallel lines. And the same picture goes for our supplementary angle side. Let's go ahead and take a look at what happens to create congruent angles. In our table, we have vertical angles as our first type of angles. So all of these are just some vocabulary to show what congruent angles we have. In intersecting lines, the angles that are opposite to each other are called vertical angles. And those are always congruent because remember, if you're closing up your arms, they hit each other at the same time. Same way for this direction. So vertical angles are always congruent. And actually, because of vertical angles, we know that all of these other relationships are true. So let's look at our picture up here. 1 and 4 are vertical angles. So we'll draw our congruency arc marks. And since we're on the same transversal, so the same exact line, and M and N are parallel, we can literally pick up angles 1 and 4 and slide them down to be right on top of 5 and 8. So 5 and 8 are not only congruent to themselves because of the vertical angles theorem, but they're also congruent to 1 and 4. The same thing goes for 3 and 2. They're congruent because they're vertical angles, and they're also congruent to 6 and 7 because you could slide it right down on that line, and that's because it's the same line and because those 2 lines M and N are parallel. So this only happens when you have parallel lines cut by transversal. So all of these are congruent, all the double arc marks and the single arc marks. So if we went ahead and looked at our numbers here, we could see that 5, 8, 1, and 4, they're going to be paired together at some point, and 6, 7, 2, and 3 will be. So for vertical angles, we have an extra image to show all the sets of vertical angles, and it's also written with the angles that are numbered in our picture. So let's talk about alternate interior angles. That's a new vocabulary. Vertical angles we learned in our first unit, but alternate interior, alternate exterior, and corresponding are new. So alternate is talking about on alternate sides of your transversal, and interior is inside your parallel lines. Alternate exterior is alternate your transversal, but exterior to your parallel lines. And corresponding is the same exact place, but the different cluster of angles. So it'd be like the top right in each piece, or the far right on your shelves. I like to think about shelves when I think about corresponding. Let's say you've got a big thing of shelves, okay? And you want to put all of your candles on the far right side, just for symmetry. You just want to make it all fancy that way. Well, you're on different shelves, but you're still on the far right side, so those are corresponding locations, and that's how you can think about corresponding angles. So let's see what angles are alternate interior. 3 and 6, they're alternate, so on opposite sides of your transversal, or alternate sides, but they're inside the parallel lines. They're between those parallel lines. Another set is 4 and 5. If we're doing alternate exterior, that will be 1 and 8. So alternate the transversal, exterior to the parallel lines. and then 2 and 7. And corresponding would be like if you looked at number 2, well, that's in the top right location of this top cluster. So top right. So what's the other angle in the top right in the bottom cluster? That's angle 6. So those would be corresponding. Our point to ponder just addresses the fact that the vertical angles theorem is the building block for knowing the alternate interior, alternate exterior, and corresponding angles are congruent. Because of the vertical angles theorem, we already know which angles are going to be congruent to each other. The other language we just learned is just for us to give a name to any two angles in relation to their locations to each other. Okay, Opties, let's look at supplementary angles. So supplementary, recall that means that you have angles that add together to equal 180 degrees. All of these angle relationships are just talking about two angles. So if you remember the special name for two angles that are supplementary, that's called a linear pair. So linear because it makes a line, remember I'm 180. And pair because it's just two angles. So let's look about how many lines can we make. So we've got 3 lines. We've got M, which is one of our parallel lines, N, which is the other, and Q, which is our transversal. Well, each line has 2 sides, the top and the bottom, okay, or the right-hand side and the left-hand side if you're looking at Q, which is tilted that direction. So let's draw those. If we look at 1 and 2, those are supplementary because they make up that line M. The under part of that is 3 and 4. Now let's look at what makes line Q. That's 1 and 3. And 2 and 4 is the under part of that. So let's take a look at what is happening with our line N and transversal. So 5 and 6 and 7 and 8. So we're marking all the linear pairs, all the angles that will add to 180, and we can tell that because they make up the line. Then we have 5 and 7 and 8 and 6. Now these arc marks where I have the dotted and the 1 arc marks, that's not to show congruence, that's just to show that they're making up that line, it's just that they're supplementary. So we've got 3 different types of situations when you have supplementary angles. A linear pair, which we just modeled, which is the building block similar to the vertical angles, but it's the building block for the supplementary angles. Then we've got same side interior and same side exterior. So remember when we just said alternate of the transversal? Well, if you're not alternate, you're going to be on the same side. So this side or this side. So the same side is referring to the transversal, and the interior, just like we had for alternate interior and alternate exterior, that's going to be talking about interior to the parallel lines or exterior to the parallel lines. So looking at our table, we see these special diagrams to show what angles we're talking about. So same side interior, these 2 angles, same side of the transversal, interior to the parallel lines, and these 2. And then exterior to the parallel lines and on the same side. That's an example of this over here. And then we've got our numbered angles to go along with our picture. So our point to ponder is similar to our first point to ponder in that we've got a building block for these supplementary angles, and it's a linear pair. If we know that 5 and 6 add up together to make 180, and that 5 is congruent to 8, 1, and 4, then 6 should be supplementary with 8, with 1, and with 4, right? So that's the thinking that's happening there. It's almost like you're using vertical angles and linear pair to make that together to show all your supplementary angles. So here is a really important thing, and this will make it a little bit easier on you when you're solving problems like this. You've only got 2 different angle measures in all of your angles if you have parallel lines cut by transversal. You've got an acute angle and an obtuse. Unless that transversal is perpendicular, then you've got only 1 angle measure, and all of them will be 90. So use your common sense and look at the picture. Not everything is always to scale, but you'll be able to tell if something's acute versus obtuse, or just at least if you can't tell that, you can tell that the angles look different in size. So if they both look acute and it's parallel lines cut by a transversal, they're probably going to be congruent. If they both look obtuse, probably going to be congruent. If you're looking at two angles and one of them's acute and one of them's obtuse, probably going to be supplementary. So use some of that logic to help you solve problems like this. All right, Opties, that's it for parallel lines cut by transversal notes. See you next time.